Okay, good morning, and we will start the next portion. Next module is combined transport layer as well as application layer. So we will start with the transport layer. So transport layer, we have many applications running on the computer. So basically, it is for the purpose of applications that we have all this network. Applications should communicate with each other. So there are several programs running on uh, computers. Now, so there should be a talking between the two processes. So the source to destination delivery means not only from one computer to the next, but also from a specific process on one computer to the specific process on another. So when you are booking a ticket or something like that, one process in one computer should talk with another process on another computer with a network in between. So the application programs we refer to as process. So that is the process to process delivery. The two processes communicate usually in a client-server relationship. So the real communication is taking place between the two processes or the two application programs. And transport layer is responsible for process-to-process delivery. That is the uh, transport layer function, main function. In addition, we have error control and flow control implemented at the transport layer. Someone at the top looking, ensuring the error control and flow control. So we can see that we had seen link layer. So this is from over a hop, node to node. These are all link layer. These are all link layer. And network layer is from here to this, through this net, from here to here. That is host to host. Now, many process running on a node and many other process running on another node. So you may keep many applications running. So one process should specifically communicate with another process. So that is this transport layer. So that is summarized here. Process to process is transport layer, host to host is network layer, and node to node is data link layer. Now, when there are many processes, you should identify. So there should be a number for the process. So amongst the many process, to which process you should deliver, that you should know. So there should be a number. So those are called port number or the transport layer address. To choose among multiple processes running on the host, port numbers are 16-bit integers. So 16 means 2 raised to 16 is, this is the figure. So these many number of processes can have numbers. This here they have written a client and a server. So there is a flow of packets from the client with a 13 and 52,000. So to get the day and time. So this is called the daytime process. From a remote machine, we need a daytime client process running on the local host and a daytime server process running on a remote machine. So there are some figures which are the numbers. So this 52,000, it is within 65,000. So this could be name of a process. So this could be the source process. This could be the destination process, which is 13. Now again, this 13 is sending to 52,000. So processes are identified by port numbers. So IP address versus port number. IP address defines the host. So IP address means a datagram reaches here to the destination, the host. IP address is selecting this host. The port number defines one of the processes on this host. So on this host, there are many processes running. So 13 number would identify a process or an application. So we had seen Internet Assigned Number Authority. They have divided, this is a central agency, they have divided this 0 to 64,000. It is actually 65,535 into 3 ranges. One range is a smaller range from 0 to 123. They are assigned and controlled by this agency, IANA. Then 1024 to 49151 are not assigned or controlled by IANA. They can only be registered with IANA to prevent duplication so that no one else will get this. So you can register with this for this range of port numbers, registered port numbers. These are well known. Normally, most of the protocols will have these well-known port numbers. So here registered, you can register so that someone else will not duplicate. And other thing is free. 49.152 to 65.535 are neither controlled nor registered. They can be used by any process. They are called ephemeral ports. So they are dynamic. Three ranges of port numbers. Now, combination of IP address. So IP address, normally we represent this 32-bit dotted decimal, the IP address, plus this port number would combinedly define a socket address. So combination of IP address and a port number is called a socket address. Now multiplexing and demultiplexing. So at the sender, there are several processes. So many packets from many processes over one transport layer. So there is a many to one relationship which require multiplexing. So many processes are running means many processes are sending sessions. Sessions is the name given to the unit of data at the transport layer. So they have to be multiplexed and it should be given to the network layer. IP should give to the data link and to physical layer. It should go in the reverse manner at the destination. So we need a demultiplexer. There is something coming, it has to be demultiplexed and given to different processes based on the port number. Now, transport layer protocol, you have two flavors. One is connectionless service, which is called UDP, and connection oriented, which is called, this is actually transmission control protocol. Okay, I just put TCP, I just expanded it as transport control protocol, but in other slides I have written the correct name, it is transmission control protocol. Now, one type of transport layer protocol called the UDP, user datagram protocol. So datagram is basically this IP, it is connectionless. So transport layer also has this connectionless service. There is no connection establishment. Packets may be delayed or lost or may arrive out of sequence because packets can travel different routes. Each packet is independent of other datagram. Every datagram are independent and they can travel in any route and they can be delayed by different values and they can be lost or they may arrive out of sequence. So there is no ACK either. So this is called UDP. Another is connection oriented service. There is a connection, circuits like similar to circuit switching, and data are transferred and then connection is released. So there are two protocols in this. One is TCP and another is SCTP. So we'll see the two types of service. UDP is connectionless, similar to IP, which is connectionless, and TCP is connection oriented. Now, transport layer service can be reliable or unreliable. Reliable means if the application program needs reliability, we should use reliable transport layer protocol. So this will implement flow control and error control, but this is more slower and more complex. So when you want more service, the complexity would increase and it would slow down the things when you want some service. So you want flow control and error control at the expense of increased complexity and slowing down of things. UDP is connectionless and unreliable. If application program does not need reliability because it uses its own flow and error control. So it's already there in the application. So it doesn't need this transport layer to implement this. Then it can use this connectionless, which is UDP. And or it could be that you need to deliver things faster. You cannot afford to lose time. So then you will go for this connectionless UDP. Or it can be that the nature of the service does not demand and flow and error control. Let's say real-time application you are doing streaming, so maybe one frame is missed or one frame is corrupted, you could make out from the neighboring frames, because maybe 25 or 50 frames are transmitted per second. You don't need to have all the frames like that. So then only option is to go for this faster one, which is UDP. So TCP and SCTP are connection oriented and reliable. So UDP is connectionless and unreliable. So you want to get move things faster. Okay. So for certain application, you will go for UDP. Certain application, you have a ticket booking, a bank, something. All these things should be TCP. So whenever you want to ensure this error-free nature and everything, you need TCP. Whenever you want some real-time streaming and things to go faster, you use UDP. Now error control. So here you see this pink color. Here this is error is checked at this path. This is the data link layer, second layer, data link layer. These pink colors, errors are checked. So error is checked in this path by the data link layer. Now error is not checked in this path by the data link layer, means these are IP based, third layer. So reliability at data link layer is between nodes. Now we need reliability between two ends. From this end to this end, we need reliability, because IP is unreliable. It is only a best effort mechanism. So this reliability would be built at this transport layer. So you will get end-to-end reliability. Now this position of this three TCP and UDP and SCTP are above the network layer, just below the application layer in the TCP IP. Now we'll see the simpler one, which is user datagram protocol, which is now somewhere something similar to this our IP itself, IP datagram. So it is connectionless, it is unreliable transport protocol. It does not add anything to the service of IP except to provide process-to-process communication, that multiplexing, instead of host-to-host communication. Instead of delivering from one host to another host, we are delivering from one process to another process, similar to just an extension of this IP. So if a process wants to send a small message and does not care much about reliability, it can use UDP. Using UDP takes much less interaction between sender and receiver than using the other two, which are connection oriented and reliable. So I talked about port number. So these are some UDP, some applications, DNS, say network time protocol, simple network management protocol. All these have, so these processes are running, means these processors should have some port number. And these are in the range of less than 1023, which means well-known port numbers. So this, you see this name of these applications, they would be in the well-defined port numbers. So these are well-known ports used with UDP. So things one should be running faster, all these things. Now UDP format. So UDP means you need a source port number. There is a data and a header. This data would be something which comes from the application layer. You would encapsulate as the data, and you would add a header. So here 16 bits, 16 bits means 4 bytes. Again 16 bits means 4 bytes, total of 8 bytes. 8 bytes is the header. So 2 bytes each for source port number and destination port number. Then total length. Okay, you are providing everywhere this total length is there. You would have observed that in IP also you have this total length of header, everything. So you have checksum as well. So length of, so UDP format is 8 bytes. So you have 4 bytes for port numbers. Length of datagram. So what is the length is header plus data. Both together is this length indicated here, 16 bits. So 16 bits you can define as up to this 64535. However, total length needs to be much less, because UDP user datagram is stored by an IP datagram which has a total length. So if you refer to IP datagram, there also you have this total length. There also you would have used 16 length bits. So this plus header should be contained within the 16 bits, or it should be a figure less than 65535, which means the user datagram would normally be less than this one to account for this header. So which is this total length which is specified in this IP. Now source. So if source is a client sending a request, then port number in most cases is an ephemeral port number requested by the process and chosen by the UDP software running on the source host. If the source is a server, mostly it would be a well-known port number. So we need not bother about that. Anyway, we have this range of port numbers defined here. Not registered that can be used by any process are the ephemeral, which is this 49152 to this, and these are the registered and these are the well known. So let it be any number. We will give this send that number in this and here, and we will keep this number of the destination port number here, and the total length and the checksum. Now the UDP length. Okay. UDP length can be calculated as the IP length minus IP headers length, also another mechanism to find out the UDP length, because UDP is the transport layer which is encapsulated by the IP. So in the IP also there is this IP length field. So you subtract the IP header length, you would get the UDP length. So that also is another way. But as a ready reference, if you get here itself, you can move things faster as a transport layer. Transport layer need not interact with the IP layer to get the length. So that is why we provide at every layer. Now UDP operation, so there is nothing much to add here. UDP provides a connectionless service. Each datagram can travel on a different path. On each request must be small enough to fit into one user datagram. Only those processes sending short messages should use UDP. The lack of flow and error control means that process using UDP should provide this mechanism. Some application layer is using this UDP means that application layer should uh, provide a mechanism for flow control and error control. Or it is that that application does not require this flow control and error control. They have more other important concerns like sending it faster, or having a low jitter or delay, or you should keep on getting the frames faster at the receiver. So under those conditions, you would choose this UDP. Now, how these ports are implemented? There will be queues. So client process start request port number from the operating system. So here the operating system and client process would have an interaction, and it would get this port number, and queues are created. So there would be outgoing packets. So when process terminates, queues will be destroyed. So when the process is started, these queues are formed, and client process send messages to the outgoing queue. UDP removes message after adding header delivers to IP. So from the application, you would put on a queue, outbound queue, and this transport layer would take one by one, and it would add the header and send it to IP, and IP would send it to data link, and this would go on. And whatever is received, it would be put on an incoming queue. So these are actually applications or processes. So UDP removes messages after adding header and delivers to IP. It delivers to IP from this queue. Now, if queue overflows, OS can ask the process to wait. So someone who is controlling all the processes is this OS. So whenever this queue is overflowing, it can ask the process to wait. Now when a message arrives, if there is no queue or queue is full, UDP would send port unreachable ICMP message. So we had seen this companion protocol in network layer. So error control and messaging protocol. So since IP cannot look after every other thing, there are companion protocols, and ICMP is one such thing. So if some case this is filled, or queue does not exist, or due to some wrong number or anything, it will send this unreachable ICMP message. Now, use of UDP. So it is suitable for a process that requires simple request response communication. It is evident. Now, suitable for process with internal flow and error control mechanism. So something like a trivial file transfer protocol process include flow and error control, which means that application or that process has that inbuilt flow and error control. So in that case, they can use UDP. Suitable transport protocol for multicasting. So multicasting capability is there in UDP, but it is not there in TCP. UDP is used for management process such as symbol network SNMP we had seen here. Symbol network management protocol. So to get things faster, we need this. So for SNMP, you use UDP. UDP is used for some route updating protocols like RIP we had seen. You want to update the route, you want to get the information delivered fast as possible, you use UDP. Now, TCP is transmission control protocol. We are not going into a lot of detail in this class. TCP is a connection-oriented protocol. So it should create a virtual connection between two TCPs to send data. In addition, TCP will use flow and error control mechanism at the transport layer. So flow and error control mechanisms are there at the transport level. Now these are certain TCP. So FTP, file transfer protocol is a TCP. So it is port number is 20. These are some well-known port numbers. So you could have find this DNS with 53 and DNS with some other port number there, which uses UDP. DNS with that DNS with 53. So it depends whether you can use this same thing under UDP as well as TCP also. It depends on the application whether you select TCP or the UDP. HTTP is using this TCP. So all these are some of the name of application and some of the well-known port numbers. Okay, so they use TCP. Now here in TCP means, so this is a stream of bytes. So this should go in order. This is delivered in order. Everything is happening in order and there is no error. This is ensured between these two processes by this TCP. So that is the advantage of this TCP. So TCP stream delivery. TCP allows sending process to deliver data as a stream of bytes and allows the receiving process to obtain the data as a stream of bytes. The two processes seem to be connected by an imaginary tube that carries data. So everything is taken care of and it is like you are having everything in order when you implement this TCP. But it is at some cost of complexity and delay. So you would have buffers and TCP segment and TCP features and numbering. So we will study these in detail tomorrow. In next class, we will see all these things. Okay. So we will have the class, continue the class tomorrow. Actually, I thought tomorrow there will be MTech admission and those things, but that got postponed to a later date. So tomorrow and Monday we'll be having classes. Okay. Thank you. You can ask anything if you need to